Hi there, welcome to this course. I really appreciate you for showing interest in this course, and I would like to answer some questions you might be having in your mind while opening this course. The first question is, who is this course for? This course is for anybody who is willing to learn the basics of Python, whether you have never written a line of code or coming from another programming language. This is the most practical guide to learn Python in 2023. I have divided this course into two sections for you. In the first section, you will learn all the basics that you need to get started with Python. And in the second section, I will teach you how to apply this concept that you covered in section 1 by building different kinds of projects. And the second question, why this course? This course will not only teach you basic Python concepts, but it will also teach you how to think like a programmer. I don't have any boring slides or another monitors that I copy paste from. I have written all the code in this course from scratch, and I will show you the kind of my thought process and how I approach different challenges. Here is a quote from Confucius, a renowned Chinese philosopher that says, "What I hear I forget, what I see I remember, what I do I understand." Project-based learning is the best way to learn any new programming language, and I promise to walk you through different projects that will help you retain the concept that you have learned in the first section of this course. And for you to follow along this course, you need to download the latest version of Python by going to python.org/downloads. You will also need a code editor. For my case, I will be using Visual Studio Code, or you can use any of your favorite code editors. And if you have these installations in your machines, you are ready to start this course. See you in the next video. Hey folks, I hope you're doing well. Welcome to this video. In this video, we're going to learn about the print function in Python. The print function allows you to display any message to the screen. You just have to write the print keyword followed by parentheses, and within the parentheses, you can write the message that you want to print out to the screen, surrounded by either double quotes or single quotes. So if you run this file, you are going to display this message to the screen. So you can run the file by just clicking this icon here, and then this terminal window will pop up and our message will be printed right there. So you can also use double quotes to surround our message, but the point is to stick whatever you have decided to use throughout your program for uniformity. If you run the file, you're going to display our message right there. So the print function also takes multiple parameters. Let's say you can print another message that says second message. Then you can have third message as well, surrounded by either double quotes or single quotes. So let's stick to our double quotes. You can say also third message. So you can write as many messages as you want, and these messages are going to be printed in one line. So if we run the file, we are going to have our messages printed in one line. So our second and third messages have been printed in one line. The print function also takes in some optional arguments. These optional arguments will help you display your messages in a certain way. These arguments are the sep, the end, file, and flash. We'll talk about the first two, the sep and the end. The sep allow you to separate your messages in a certain way. Let's use the sep, separate our messages using a space, so there will be no change because this is the default way of displaying your messages. So the first message and the second message are separated using a space. So this is the default way and there's no change. Let's say we want to display our messages separated by underscore. So our first message and the second message is separated by underscore. Our second message and our third message are separated by underscore. So this is just a way of summarizing your messages. You can also separate them using a plus, and our messages are separated by plus. Second message and third message separated by plus. And that's how we separate our messages using the sep argument. Before we talk about the end argument, let's write another print function that says new line. Now, if you run this file, Python is going to print each print function in its own line. So if you run the file, it has printed the first print message and then go to a new line and print the second message of the print function. So Python print functions by default ends with a new line, and it looks like this. End is a new line, which is \n. So this \n in Python means new line. If we run the file again, there will be no change because this is the default way that the Python print function ends. Now you can customize whatever that you want to print or to end with your print function. You can decide to end with underscore underscore r underscore underscore. Now it will combine these two print functions, display them in one line, and it will end the first print statement with whatever you have specified here. So if you run the file again, has combined the whole of the two print messages and then end the first print message with whatever you have specified in your end argument. We may also decide to use our SEP argument and our end argument at once. So we may decide to separate our messages using maybe asterisks and then end our print function using this underscore 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 underscore. If you run our file, our first message, our second message, and our third message will be separated using this asterisk, and then our first print function will end with this underscore underscore r underscore underscore. And that's the end of this video. I hope you learned something. See you in the next video. Hello and welcome to this video. In this video, we'll talk about variables. But before we talk about variables, let's recall algebra expression that we used in math. In algebra, we used to say something like x is equal to 4, y is equal to maybe 6. In Python, we consider this x and y as container for storing these corresponding values. And we refer these containers as variables. Now, a variable is just a container for storing data values. You can also consider these values as the actual data that's stored in a computer memory location, and the corresponding variables, consider them as a label for that memory location where the actual data is stored. Hence, a variable can also become a name that is associated with a memory address containing an actual data. Let's try to add these x and y values. If I try to add x with y, when Python is executing this line of code, it will replace this x with the value that is stored within the x variable, which is 4. And it will add that 4 with the value that is stored within the y variable, which is 6. So Python will replace these variables with the values that are stored within the variables, and it will add those values. So let's store whatever the outcome of this addition in a variable called z or z, whatever you can call it. So this z will store the addition of this x and y values, which is 4 plus 6. And if you try to print that z variable, it will give us the outcome of 4 plus 6, which is 10. In Python, not only can we store numbers in a variable, but you can also store textual data in a variable like this one earlier. And we call this textual data strings. A string is any text that is either surrounded by double quotes or single quotes. And we also have number data types. Number data types in Python is categorized into two. A number in Python is either an integer, which is just a whole number, whether positive or negative, or we also have floats. A float is any number that has a decimal point, like 4.5 or 4.3, 4.1, whatever. So any number that has a decimal point, whether positive or negative, in Python we call that number a floating point number or just a float. We also have Boolean data type in Python. Boolean data type evaluates either to true or false. So Python first checks a condition. If that condition evaluates to false, it will return false. If that condition evaluates to true, it will return true. Let's say we said something like 1 is greater than 5. We all know that 1 is not greater than 5, and this is not true. So Python will be like, is 1 greater than 5? And it will be like, no, that's not true. And it will return false because this condition evaluates to false. And let's say we stored whatever this condition evaluates in a variable called a, and try to print that variable a, and run our file. So Python will return false because this condition evaluates to false, and 1 is not greater than 5. Let's try a true Boolean statement like 1 is greater than 5. We all know that 1 is greater than 5, and this is true. So if we run our file, Python will return true because this condition evaluates to true. We can also specify the data type of our values when we are defining it to a variable. Let's say, as we know, that any number with a decimal point is of type float. So we can specify the data type of that number by surrounding it with the float keyword or the float function. We can also surround our whole numbers with the int function. As we know that any whole number is of type integer, and this int is denoted from the word integer. We can also specify our strings or our textual data by surrounding it with str, which stands for strings. Also, our booleans, any condition that evaluates to either true or false, we can surround it with the bool keyword or the bool function, which stands for booleans. And this is a valid way of writing our Python code, and we will not encounter any errors when we run this code. If you don't explicitly define the data type of our values, Python will do that implicitly behind the scenes whenever we define a value to a variable, and it will convert that variable or that value into its corresponding data type. So it will first check, is this a text or a number? If it's a text, it will convert into its corresponding data type, which is a string. If it's a number, it will convert into its corresponding data type, whether integer or a float. Let's say, for example, you have defined a variable lang, which stands for language, and assign it to a value Python. So if you try to print this lang, it will give us the value that's stored within that variable, right? Wait for a while. Yeah, it will return this Python value that's stored within the variable lang. So, and this boolean is coming from, this true boolean is coming from this. Let's just comment it for now. You can also check the data type of any value that Python has implicitly defined behind the scenes by using the type function. And whatever you specify within this parenthesis of the type function, Python will return to you its data type. For example, if you want to check the data type of this Python function because you have not explicitly defined its data type, and Python will do that behind the scenes. If you want to check its data type, you can access it through this variable lang and specify that within the parentheses of our type function, and Python will return to us its data type. Let's print out that data type by using the print function. So if we try to print that data type and by running our file, Python will return to us str, which means string. So the data type of this value has been defined implicitly behind the scenes immediately after assigning it to a variable. We can also check the data types of our other variables x, y, and r by printing it down here. Print the type of our data type x, and I can copy this for our data type y and r and replace this with our variable y, also for our variable r or a, whatever you call it. If I run this file, you're going to print the type of this variables. It is returning this string first, which is coming from our variable lang that has this variable Python text. This float is coming from our variable x, which has a number with a decimal points. This integer is coming from our variable y, which has this whole number 6. And this boolean is coming from our data type r, which has this boolean condition. And I hope you learn how to use this type function to check the data type of any value. Hello and welcome to this video. In this video, we'll talk about some rules or some conventions you have to follow when you're writing variable names. So the first rule is you must start your variable names with either a letter or an underscore character. Like our fruit variable here, obviously it has started with a letter F, so this is a valid way of writing our variable name. The second valid way of writing our variable name is starting it with an underscore, like this, underscore language. So if you're starting your variable name with something that's not a letter or an underscore character, you will encounter an error. Let's say we decided to start our fruit variable with a number. It immediately turns red, and Python will give you syntax error. So if you also decide to start our variable name with special characters like $, or maybe asterisks, or even hyphens, Python will give you syntax error. So as long as you are starting your variable name with something that is not a letter or an underscore character, Python will give you syntax error. I hope that is clear. Our variable name can only start with a letter or an underscore character. Going to our second rule, it says that our variable name can only contain alphanumeric characters and underscores. By alphanumeric, we mean that it can only contain alphabets and numeric characters or numbers. So our variable names cannot start with a number, but it can contain a number at the end or at the middle, which is a valid way of writing a variable name. It can also contain underscores, maybe at the beginning, at the middle, or at the end. But the most common way of using underscores in variable names is when you are separating two words in a variable name. Let's say you have something like favorite language. You are separating this fav and this language using an underscore. This makes our variable names more readable. Going to our third rule, it says that our variable names are case sensitive. By this we mean that these three variable names, dog that is in small letters, or a dog that is beginning with a capital letter, or a dog that is in caps, are three different variable names in Python. Our fourth rule says that a variable name shall be descriptive and relevant to its corresponding value. Also by this we mean that, example, if you have a variable name color, you are expecting something that's related to color within the value that is contained within this variable color. What if a person has defined a variable name color and he is having a value that is totally irrelevant to its corresponding variable? Maybe something like a monkey. People will wonder, oh, color is equal to monkey. How? This doesn't make sense at all, right? So we are expecting maybe a color red or white or something like that, something that is relevant to its corresponding variable. Our fifth and last variable rule says that you should not use any keyword or any special keyword in Python as a variable name. And these are the examples of special keywords that are in Python, that we have in Python. So, for example, if you try to use any of these special keywords as a variable name, let's say none equal to some value, we'll have an error. Let's begin at the. So you will have an error saying the syntax error cannot assign to none, something like that. So you cannot use all of these special keywords as a variable. Okay. And this is the end of our video. I hope you learned something. See you in the next video. Hello everyone, I hope you're doing well. Welcome to this video. In this video, we will learn about the input function in Python. The input function will somehow allow us to communicate with our users by prompting them to enter some data. So it will help us collect data from our users. For example, instead of us writing this name value all by ourselves, we want to allow our users to enter their own name. And we can do that using the input function. And within the parentheses of this input function, we want to write the message that we want to prompt to the user, surrounded by quotes. Maybe a message like enter your name, and then we will provide some space for the user to type in. And whatever the user has entered within this prompt, we want to store it in this variable name. After that, we want to print to the user, hey, your name is, and I want to concatenate this string, our name variable. Let's run our file. It will first prompt us to enter our name, let's say Ali. Then it will print to us, hey, your name is whatever you have entered as our name. Hey, your name is Ali. We also want to collect the age of our users and store it in a variable age. This variable age will be a prompt that says enter your age. After telling our users what their name is, we want to print to the user how old they are, so I can concatenate it at the end of this string that says you are, then plus whatever the user has entered as their age, plus another string that says years old. Let's run our file. Enter your name, Ali. Enter your age, let's say 24. Hey, your name is Ali. You are 24 years old. But as you can notice here, there is some collision between our variables and our strings. So let's provide some space so that it looks more readable. I can provide some space at the beginning of this string, at the end of this string, so that I can separate these variables with these strings. Also separate this variable with this string using a space. Let's run our file again. Enter your name, Ali, 24. Hey, your name is Ali. You are 24 years old. And that's how we collect inputs from a user using the input function. Now that we have learned how to collect inputs from the user using the input function, let's build a simple calculator that adds two numbers. We are going to collect these two numbers from our users and store it in a variable. Let's say variable num1 will be a prompt that says enter a number. We are going to collect these numbers from the user and store it in this num1 variable. We also want to have num2 variable. It's equal to a prompt that says enter another number. We are going to store it in this num2 variable. So we want to add this num1 and this num2 that the user has entered and print the result to the user. So it will be num1 plus num2 And whatever the outcome, we are going to store it in a variable called total. For that, we will print to the user the total of the two numbers. So the total of the two numbers is, using our total variable, you can concatenate it using a plus sign. So let's run our file. It will first prompt us to enter a number, let's say maybe 1, enter another number, maybe 3. And our program has printed to us that the total of the two numbers is 13, and that's not what we are expecting. We are expecting our calculator to add this 1 with this 3 and give us the result of 4, right? So, but it has treated this 1 and 3 as strings and just combined them together. And that's not what we want. We want to add these two numbers, and you can do that by converting our input function from strings to integers. Any input value is by default a string. Any value that you have collected using the input function, even if it's a number, is by default a string. So we have to convert it from string into an integer using the int function. And you can do that by surrounding our inputs with the int method that will convert our strings into integers. This int method will be surrounded with this input function, and then it will do it for us. So let's run our file again. Enter number 1, enter number 3. And our program has crashed again after we have entered this 1 and 3, giving us this type error that says you can only concatenate strings, not integer, into strings. And this type error is raised when we are trying to combine two different unrelated types of objects in Python. And this error is coming from our print function this time and has nothing to do whether our numbers are strings or integers, because we have already converted our numbers into integers, right? So within this print function, we are trying to combine this string and this total integer because our numbers are of type integer this time because we have already converted. So Python cannot combine two objects of different type because this is a string and this is an integer. What you can do is to convert this total into a string, and you can do that using str method. Now if we run our file again, it's giving us an error. Oh yeah, it's okay. So if you run our file again, we enter a number 1, enter another number, maybe 3. Now it has printed that the total of our two numbers is 4, and that's what we wanted. And the point of this calculator program was for you to learn that any input value will be by default a string even if you have entered a digit in the prompt, and you will have to convert it from a string into an integer using the int method if you want to work it as a number. Let's say you have entered a 3 in the prompt, so this 3 will be by default a string, and you will have to convert it into an integer using the int method. And by that you will have a 3, which is a whole number. And that's the end of this video. See you in the next video. Hello everyone, welcome to this video. In this video, we'll dive deep into data types in Python one by one, and we'll start with the numbers in this video. A number in Python is either an integer or a float. Integers are whole numbers, whether positive or negative. And these are the examples: 2, -3, -40, 56, 1, and so on and so forth. And a float is a number with a decimal points, like 9.0, 4.2, 3.0, so on and so forth. You can check the type of a number or type of any object in Python using the type function. And whatever object you want to check its type, we define it within this parenthesis of the type function. Let's say we want to check the type of 4.9. We know that any number with a decimal point is a float, right? So let's print this onto the screen using the print function. Print the type of 4.9 on the screen. Let's run our file. And Python will tell us this 4.9 is of type float because it has a decimal point. We can check the type of a whole number, maybe 9. Let's run again. So it is returning int, which stands for an integer. So any whole number, whether positive or negative, is an integer in Python. Let's also talk about some arithmetic operations you can perform on numbers. The first one is addition using the plus sign to add two numbers. Subtraction using the minus sign. Division using a forward slash. We also have floor division using 2 forward slashes, and we'll see the difference between this division and this floor division in a bit. We also have multiplication using asterisks. We also have exponents, and we use this exponent when you are raising a power to a number. We also have modulus to check the remainder of a number. Let's talk about the addition first. So we can add two numbers. For example, 4 plus 2 using the plus sign. We know this basic mathematical operation, right? Let's store it in a variable called num. Let's print this num onto the screen in the print function. If you run our file, it's going to give us 4 plus 2, which is 6. So it has returned 6, right? You can also use the minus to subtract two numbers. These are just basic math operations that everyone knows. So 4 minus 2 is 2. Let's talk about the interesting part now. Division using a forward slash. You all know that 4 divided by 2 is 2, but this division is returning 2.0. So it is returning a float. If you want to return a whole number or an integer from a division, you have to use the float division with the two forward slashes. So this float division will return an integer or a whole number. So if you run our file again, it will divide 4 by 2. 2 goes 2 times into 4, and it returns 2, which is a whole number. So if you want to return an integer after dividing two numbers, we'll have to use this float division, which has two forward slashes. And otherwise, if you want to return a decimal point number or a float, you can use one forward slash, and that's the difference between this division and this float division. This float division returns an integer, and this division returns a float. So let's talk about the rest of our operations. You also have multiplication using asterisk to multiply two numbers. So you can use asterisk to multiply 4 by 2. So 4 by 2 is obviously 8, which we have it right there. We also have exponent, and we use exponent when you want to raise a power to a number, and we do that by using two asterisks. This is like saying 4 raised to the power of 2. Let's run our file. 4 raised to the power of 2 is 16. Hopefully we get 16, and we have it right there. And our last arithmetic operator is modulus, and we use modular when you want to return the remainder of two numbers after dividing them. And we do that using the percentage sign. For example, if you want to return the remainder of 4 and 2 after dividing it, it will return 0 because there will be no remainder, and 2 goes into 4 2 times perfectly. So let's have a number that will give us a remainder. Maybe 7 into 2. This will give us a remainder. So 2 goes into 7 3 times, and there will be 1 left over, which is the remainder that has been returned. Let's also check maybe 15 into 7. 15 modulus 7 will return 1 because 7 goes into 15 2 times, and there will be 1 left over. Let's try 16. 16 modulus 7 will return 2 because 7 goes into 16 2 times perfectly, and there will be 2 left over, and it will return that 2 remainder. The most common use case of this modulus operator is to check whether a number is an even number or an odd number. Let's try an example. For example, if you want to check whether this 16 that's stored in this num variable is an odd number or an even number, we will say if num modulo 2 is equal to 0. By this we mean that if this 16, when it has been divided by 2, if it returns 0, print to the screen that is an even number. Because any number that's divisible by 2 will return 0, and if that number is not divisible by 2, it will return a remainder. Else, if that number returns a remainder, print to the screen that is an odd number. I know we have not covered this if-else statement yet, but we are going to cover it in our upcoming videos. So even if you don't understand it right now, don't worry, we're going to cover it. So what we are trying to say is, if this 16 is divided by 2, returns 0, that's an even number. Otherwise, if it returns a remainder, that is an odd number. Let's run our code. It will print even number because 16 is divisible by 2. And what Python does is that it first checks the condition in our if statement, and if this condition becomes true, it will run the code that is within that if statement and ignore the else part. And if this condition in our if part becomes false, it will proceed to the else part and print the else part. So let's say we try a number that's not an even number, like 15. So it will check whether it's divisible by 2, and this condition becomes false, and it will proceed to our else part and print our else part, which is an odd number. And that's the end of this video. I hope you learned something. See you in the next video. Hello everyone. Welcome to our numbers data type part 2. In this video, the first thing we are going to look at is how to increment and decrement a variable. Let's say you have a variable num assigned to number 2. If you want to increment this num variable by 1, the most direct way is num plus 1. If you store this in a new variable num, this new num variable is now equal to our original num variable, which is 2 incremented by 1. So this num variable will store 2 plus 1, which is 3. If we print this new num variable into our screen by running our file python numbers.py, this will return 3, which is our original number 2 incremented by 1. So instead of saying our new num equal to our original number incremented by 1, there's a shortcut version of this, and the shortcut is our num plus equal to 1, and this will take our original number and increment it by 1. So if we run our file again, it will also return 3. But you can also use multiplication to multiply our original number by 10 using this shortcut version, which is just num multiplied by equal to 10. And this will take our original number, which is 2 multiplied by 10. So it will return 20, hopefully, which is right there. The second thing that we're gonna look at in this video is the built-in method that's available for us to work with numbers. So let's comment out this part. The first inbuilt method that we're gonna look at is ABS, or absolute value. And this absolute value takes in a negative value or a positive value, and it removes the negative sign from the number and return the number. Let's say, for example, we have 4.987. So this absolute value will remove the negative sign from the number and return the number. Let's store this in a variable, maybe a, and print this here onto the screen. Let's run our file. So it has returned the number without the negative sign. If let's say if you also have a positive number, a positive value plus 5.987, so it will remove also this positive sign and return the number. Let's store this in a variable v, print out this v variable. If you run our file again, it also return the number without the positive sign, and that's the function of this ABS method. It removes the negative or the positive sign from the number and returns the number. We also have another inbuilt method, and that's the round method. This round method takes in a float number and rounds that number into its nearest integer value. Let's say we have 3.987. So this round method will round this number into its nearest integer value, and this rounds off to almost 4. So if you store this in a variable num and print this num onto the screen, run our file, it has returned 4 because this 3.98 rounds off to 4. So it takes in a float number and rounds that float number into its nearest integer value. Let's say we want to round off 3.123. If we run our file, it will round it off to its nearest integer value, which is 3. This round method also takes in a second argument, which determines how many decimal places you want to round to. Let's say I want to round this number to 2 decimal places. So if I run my file, so it will return 2 digits after the decimal point. Let's also say if you want to round it to 3 decimal places, run our file again, it will return 3 digits after the decimal place, and so on and so forth. In the last part of this video, we are going to learn how to compare two values using comparison operators. We use comparison operators when you want to compare two values and it returns boolean. So, and these are the operands that we have when you want to compare two values. You use less than if you want to check if a number is less than another number. You can use greater than, you can use less or equal to. We also have greater or equal to, and not equal to. Let's cover these operators one by one, starting with the less than. Let's say if you want to check whether 2 is less than 5, we use the less than sign. So let's store this in a variable num. And let's print this num onto the screen. The less hand operator first checks if the left hand value is less than the right hand value. So, and if so, it will return true, otherwise it will return false. Let's run this code. It will return true because 2 is less than 5. Let's check if 2 is less than 0. Run our file. It will return false because 2 is not less than 0. You can also use the second operator, greater than, to check if 2 is greater than 0. Clear the console. Run the file again. It will return true because 2 is greater than 0. You can check if 2 is greater than 5. It will return false because 2 is not greater than 5. You can also use the other operator, less or equal to. You can check if 2 is less or equal to 5. It will return true because 2 is less than 5. Let's check if 2 is less or equal to 1. It will return false because 2 is not less than 1. You can also use the greater or equal to sign. You can check if 2 is greater or equal to 1 using the greater or equal to sign. Run our file. It will return true because 2 is greater than 1. We also have equal to. You can check if 2 is equal to 1 using this double equal to sign. If you run our file, it will return false because 2 is not equal to 1. Don't confuse this equal operator with the assignment operator. We use the assignment operator which has one equal sign, maybe when you are assigning a value to a variable. So this is assignment operator and this is comparison operator. We also have not equal to. If you want to check if a value is not equal to another value, for example, here we compare if 2 is not equal to 1, which is true because 2 is not equal to 1. We can also check whether 2 is not equal to 2, and it will return false because 2 is indeed equal to 2. So this not equal to operator returns true when two numbers are not equal. And that's the end of this video. I hope you learned something. Hello everyone, welcome to this video. In this video, we'll talk about string data types in Python. Strings are considered as any textual data that is surrounded by either double quotes or single quotes. For example, let's say we have a variable myCourse assigned to a value Python tutorial. So this text that has been surrounded by double quotes, we refer to it as string in Python. We can also surround it using single quotes at the end and at the beginning of our text. Let's consider a case where we want to use apostrophe within our string. Let's say, for example, Alice course. We want to have apostrophe before the S, and if you want to have apostrophe within a single quote string, we'll have to tell Python that we have not ended our string here, because Python will think that you have ended your string here and the rest is an invalid code giving you a syntax error. So, and there are multiple ways you can do that. Firstly, we can surround our strings using double quotes, and you can have single quotes inside it, so the error has gone. Or if you want to stick with your single quote string, you can use something called escape characters. An escape character is just a backslash followed by the character that you want to use. For example, here apostrophe, and you are telling Python that this is not meant to be the end of our string, and it will treat it as part of the string. If we print this quotes variable, my quotes variable, and run our file, you are going to get an apostrophe within our string, Alice course. The same case applies to our double quote strings. Let's say you want to have a double quote string Alice course surrounded by double quotes, and you want to have a double quote within our double quote strings. Maybe in place of this apostrophe, you want to have a quote, and Python will think that we have ended our string here, and will treat the rest of our code as invalid. And you have to tell Python that this is not invalid, and we just want to have a quote within our string. And we can use also escape characters, and it will treat it as part of our string. If you run our file, it's going to print Alice course and treat this quote as part of our string. We also have other escape characters that we can use in our string. For example, let's say if you want to print a tab within our string, we'll have to use backslash then followed by T, which stands for tab. And that will print tab within our string. Right there. We can also print a new line within our string by using \n. If we run our file again, whatever comes before the backslash will be printed on a new line, and whatever comes after the backslash will be printed on a new line. Like that, Ali and then S course on a new line. You can also print a backslash within our string by using backslash after the escape character, and the backslash will be printed as a part of our string. The other way you can use quotes within our strings is to use a multi-line strings. Multi-line strings are strings that are surrounded by triple quotes. Let's make this a multi-line string by printing into the next line. So we are going to have a syntax error unless we make this string triple quotes. If we surround our quotes with triple quotes, either triple double quotes or triple single quotes, Python will identify this string as multi-line string, and you can print as many lines as possible within our string. Let's say Alice course is about Python language, and print as many lines as you want. You can even use apostrophes like here in your string. Maybe it is meant for Udemy students who wants to learn Python. As you can see here, I have used apostrophe or a single quote within our triple quote. I have also used it here, so it will be a valid way. If you print this multi-line string, so it's going to print whatever you have placed, whatever quotes you have placed within your string, and it will be treated as part of our string. So as you can see here, we can also make this string triple single quotes surrounded with three quotes, surrounded with three single quotes, and also Python will treat it as multi-line string. You can have single quotes within our string. Let's also look at row strings. Row strings are strings that ignores all escape characters in a string and prints any backslashes that appear in the string. Let's see an example. Let's say if you have a single quote string that says, maybe please rate Alice course, and if you escape this apostrophe using escape character, Python will treat it as part of the string, and if you print it onto the screen, so it will appear as part of our string. But if you use a row string, let's say a prefix with an R before our beginning quote, Python will also treat this backslash as part of our string. Let's run our file. It has printed both backslash and the apostrophe, which means that Python will ignore all escape characters that appear in a string when you are using row strings, and it will also print any backslash that will appear in a string. Row strings are very helpful when you are typing string values with many backslashes. And a good example of using row strings is when we are trying to print out a string value that contains Windows file path. For example, if I try to print these files, Windows file path, it's going to look like this. It begins with cap C, colon, backslash, users, then slash Ali, then our folder's name, Python. Then within the folder, you have our strings.py file. So Python will treat these backslashes as part of our string when we are using row strings. If I try to run our file, all the backslashes are going to be printed as part of the string. So this is most helpful when you are trying to print Windows file paths like this one. Let's talk about indexing and slicing strings in Python. When you define a string in Python, it will assign each character that appears in your string to a corresponding index number and it starts from 0. Let's say we have a string that says please rate this course, and I hope you guys will leave your feedback whether you find this course helpful or there is something I can improve on. Your feedback will be highly appreciated. Take a minute now and leave a rating and your feedback. Thank you. So let's say we have a string that says please read this course. When you define a string like this, Python will assign each character, for example, PLES, each character that appears in our string to a corresponding index number and it starts from 0. So it will assign the first character to an index 0, the second character to index 1, 2, 3, and so on and so forth. And you can access these characters using the index number that has been assigned by Python. We can get any character in our string using its corresponding index number. Let's say, for example, if we want to get P, which is our first character in our string, so it's starting from index 0. So if we specify that within, of course, you're going to use our variable because our string is stored within this variable, my course. So if we specify the index that you want to get from our string using these square brackets, for example, let's say 0, and store this variable in another variable, let's say maybe my course or my character equal to this, and if you print this character, you are going to get the character in position 0, which is P, and it has printed P. Let's also specify index maybe 4. What do you guys think we'll get? So it will start from 0, 0, 1, 2, 3, 4. So this S is the first index, and it will return the position at that index, which is S. You can also specify maybe 7. If you run our file again, it's returning R. So let's count 0, 1, 2, 3, 4, 5, 6. Any space is counted that appears within our string. So the 7th is the R. Any space and any special character like this one is counted. Let's say, for example, if you want to print the length of our characters, you can use the length method, and then specify our variable where our string is stored. And if we print the length of our characters, it has returned 24, which are just the number of characters in our string. So the length starts from 1 and index starts from 0. Please don't confuse. So let's count the length. 1, 2, 3, 4, 5, 6, 7. Spaces are also counted. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Also symbols like this exclamation marks are counted. So the length is just the number of characters and starts from 1. Index starts from 0 and it's the position of our characters. We can access a range of characters using the index. Let's say my course, using square brackets, you can access a range of characters. So this is the first one is where the range, our index range will start, and the last one is where our index range will end. So the last one will not be included. Let's just print and see it for ourselves. It will include the first range, which is P 0, 1, 2, 3, 4. So it will not include the last index range. And if we leave off, for example, first range and just print the last range, it will start from the beginning and print to where you have specified to end your index range. Let's also maybe say we want to start at index maybe 9 and we don't specify the end range. So it will begin from the ninth range and it will print the rest of the index range. So it is beginning from this T of this red. Let's try to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has begun from the start index to the end if you don't specify the last index range. And that's how you can access a range of characters by just specifying the range using square brackets. We can also access the characters in our strings backwards using the negative sign. So this first one will begin with -1, -2, -3, -4, and so on and so forth. So if you try to access it, a cos, and then within the square bracket, if you try to access the -1, so that's the beginning backwards. So it will return this symbol or this exclamation mark, which is at the end of a string. We can also maybe access -4th index, and it will return the character in that position, which is R. So let's count -1, this symbol, -2, -3, -4. Also, you can return a range of characters, let's say from -4 up to the end. So it starts from -4th position. It's starting from R, -1, -2, -3, -4. We have not specified the end index range, so it's going to go up to the end of our string, and it has returned from R to the end. Hello everybody, welcome to this video. In this video, we're going to look at different ways you can format our strings. Before, you have been using string concatenation or the plus sign when you want to combine two strings. For example, if you wanted to print my name is, and then this last name and this first name, we will copy this and then concatenate our strings to this variable using the plus sign, and then add another plus sign and concatenate this last name variable. If you run our file, it's going to join our strings together, but it's just combine them, so you have to remember to add spaces between your variables and also between your variable and your strings. You can add space here and then the plus sign. If we run our file again, you can see now it has printed in a more readable way. But this is very tedious because you have to remember to add a space, you have to remember to concatenate using the plus sign. So there is a better way of doing it. And the easier approach to do this is to use the .format method instead of combining our text and our variables using the plus sign. And just use curly braces where we want to put our variables. For example, we want to put our first name variable after my name is, and then our last name. So this will act as a placeholder for our variables. And then after the string, we can put our .format method, and within the parentheses of this method, we are going to use our variables first name, comma, last name, and this first name is going to correspond to the first placeholder curly brace, and the last name is going to correspond to the last placeholder of our curly brace. If we run our file, it's going to print perfectly and clearly that my name is Ali Hassan. The second approach will be to use f string. For example, if you wanted to print my name is, we are going to place our curly braces again, but this time we are going to use our variables within our curly braces. So it's going to hold our variables first name and then our variable last name, And for these variables to work, we are going to prefix our string using an f string, just like we did using the raw string to prefix an r. So, and if you run our file, it's going to print as we expected. My name is Ali Hassan, and I consider even this approach, this f string, better than this one. And this will be the end of this video. I hope you learned something. If you find this course helpful, please leave a good rating and a feedback for the course, and see you on the next video. Bye bye. Hello everyone, welcome to this video. In this video, we will talk about the methods that you can use to manipulate strings. These are built-in methods that will help us to transform our strings in a certain way. We will cover the most often used method, starting with the upper and the lower method. We can use the upper method to convert our string values to uppercase, and the lower method to convert our string values to lowercase. Let's say we had hello world string. If you want to convert this string to uppercase, we will use .upper, and we will prefix our method using the dot. If we store this in a variable, maybe a, and print variable a onto the screen, it will return our transformed hello world string to uppercase. You can also use the lower method. Run our file again. It will also return our hello world transformed to lowercase letters. We can also use other methods. For example, as soon as we press dot, you will have so many methods that you can use on these strings. So let's use capitalize method. What capitalize does is that it converts the first letter in a string to uppercase and the rest will be in lowercase. Let's run our file. So it has converted the first letter in the string hello world to uppercase and the rest is in lowercase. We also have the strip method that will help us to remove any spaces from our string. Let's say we had spaces at the end and at the beginning of our string hello world. If we run our file again, we are going to print spaces at the end at the beginning of our hello world. If you want to remove any spaces that's contained within a string, we will use the strip method. So if you use strip, run our file again, it's going to print our hello world string without the spaces. So we remove any spaces, any tabs using the .strip method. If we wanted to remove white spaces only at the right of our string, we will use rstrip. This rstrip will remove any white space at the right of our string. If we run our file, it's going to remove white spaces from the right side of our string. You may not see it because it's the end, but if you use lstrip, it's going to remove any white space at the left of our string. If you run our file, it will return our hello world starting at the margin or at the beginning of our string. There are some methods that you can use to check whether our string is in uppercase or in lowercase. If we first remove the white space from our string and check whether our string is in lowercase using .slower method, and this method will return true if our string is in lowercase, otherwise it will return false. And now it's returning false because our string contains uppercase characters. Let's convert them into lowercase. So right now our string is in all lowercase, and if we run our file again, it's going to return true. We also have .isUpper, and this .isUpper returns boolean also, and it checks whether our string is in uppercase or in lowercase. If we run our file, it will return false because our string is in all lowercase. Let's first convert our string to uppercase. Hello world. If you run our file again, this time it's going to return true because our string is in all lowercase. We also have the .isUnlearn method. .isUnlearn method returns true if the string consists of only letters and numbers. Let's say we had a string that contains only letters and numbers, for example Ali 23, when we confirmed using the .isAlnum method, so, and this method will return true if a string consists of only letters and numbers. And it has returned true because our string consists of Ali, which are letters, and 23, which are numbers. Let's say we had something else in our string, like a $sign or an hash. If we run our file again, it's going to return false. So you can use it to validate if a string contains only letters and numbers. We also have the title method. The title method returns true if a string consists of only words that begin with an uppercase letter. Let's say, for example, we had a sentence that says, this is a title, and you can check whether this string is a title using the title method. So this title method will return true if every word in our string begins with a capital letter. If you run our file, it has returned false because a word in our string begins with a small letter, and if we change that to a capital letter, run our file again, it's going to return true. And you can use this title method to validate whether every word in a string starts with a capital letter. For example, if you have a list of strings, you can check them if those names start with a capital letter. We also have the .numeric method, and this .numeric method will return true if a string consists of only numeric characters or numbers. Let's say, for example, we had a string that contains only numbers, just random numbers, and check whether this string contains only numbers using the .numeric method. This method will return true if the string contains only numeric characters or numbers. If we run our file, it has returned true. Let's say we had a special character like dollar within our string that's not a number. If you run our file again, it's going to return false. So you can validate any string using this numeric character, whether that string contains only numbers or something else. Let's talk about list in Python. A list is a data type just like strings and numbers that stores a list of items using square brackets. Let's define a list of items and then store them in a variable myList. We define myList variable, then assign it to a list of items using square brackets, and this item can be of any data type. It can be numbers, strings, and so on. So let's start with numbers, maybe 145, and maybe you can have some string like hello, and we separate these items using comma. Let's print this list onto the screen. If I print my list variable and run our file, it will return our items surrounded with square brackets. We also have methods that you can use to modify our list. For example, if I want to add a new element into our list, I will use .append method on our list. Let's say my list.append, and then the element or the item that I want to add into our list. Let's say, for example, if I want to add world onto our list and run our file, it's going to return our list and then the new item appended at the end of our list. What this append does is that this method appends an item at the end of a list. And if I want to add an item at a specific location in a list, I will have to use the .insert method. The .insert method will let you specify the location index where you want to add your list item and then the item itself. Let's use the .insert method on our list. So it takes two arguments. The first argument is the location index where you want to insert your list item. For example, let's say if I want to insert an item at the beginning of our list, I'll use the 0 index because a list is also a 0-based index. The second argument is the item itself. Let's say I want to add world. If you run our file again, it's going to return our list with the world item at the beginning of our list. So this insert method will give you that flexibility to add an item where you want. It's more like the append method, but it gives you that flexibility to add an item at a certain location index. We also have the join method. The join method joins a list of strings into one single string value. For example, let's say you had a list of strings. If I convert these numbers into strings by surrounding them with quotes, I can also add this world string to our list at the end here. And if I want to use the join method on this list of strings, I will first have to define what I want to separate with my string values after joining them. So let's first say I want to separate my string values using space, underscore space, and then I will use the join method. I will define what I want to join. I want to join this list of strings. I can use the variable my list. Let me store this in a variable, maybe list2, and I want to print this list2 onto our screen and see what we have returned by running this file. And it has returned our values after joining our list of strings under one string value, and this is the same as saying I have all these values under one string. So it has joined them. It has joined this list of strings under one string, so they exist under the same string, in other words. And it has separated these strings values with whatever we have specified on this join method. So if, let's say, if you want to separate our string values with a plus sign, run our file again, so it's going to return our values separated by the plus sign. So you can specify whatever you want to separate with your values here before calling the join method. We also have the split method that does exactly the opposite of the join method. The split method returns a list of strings when you call it on a string. Let's say that we had these values as a string stored in a variable. So if we store this as a string in a variable list3 and use the split method on this list3, split. So the split method is going to return the list version of this string. So after converting it into a list, let's store it in a variable and print that variable a. If you run our file again, it will return the list version of our string. So the split method has converted our string into a list, and the join method, it transforms a list into a string. So they do exactly the opposite. Hello, I hope you're doing well. Welcome to this video. In this video, we are going to learn about the if statement in Python. The if statement will help us to make decisions in our programs whether to execute a certain code or not. The if statement consists of an if keyword followed by a condition that evaluates true or false. It also ends a colon. After this colon, if you hit enter, it will indent your code. Whatever code that is written within this indentation will be executed only if this condition evaluates true. Let's say we had a variable name that's equal to mark, and we want to check if this name is equal to mark. So if name, so our condition will be if name is equal to mark, we want to print you are mark. So we want to execute this block of code if this name is equal to mark. Let's run this file. It will print you are mark because the condition is true. As long as this condition evaluates to true, it will run the code that has been indented below it. Let's change this name to Ali. So it will first check if the name is equal to mark. When this condition returns false, it will skip the whole of this if statement. So it will not print anything. If you run our file again, it has not printed anything. We also have the else statement, and this else statement will get executed only when this if statement evaluates to false. Let's print something else under this else statement. So it will first check if the name is equal to Mark, and when this condition evaluates to false, it will skip the whole of this if statement and proceeds to the else path. It's like saying do this, otherwise do this. So if this condition evaluates to false, it will execute whatever that is in the else statement. We also have an elif statement that we use when you want to check for multiple conditions. Let's say we also want to check if the name is Ali. So elif and then the condition, if name is Ali, we want you to do or print you are Ali. If we run our file, it will first check if the name is Mark. So this condition returns false, and then it will skip the whole of this if statement and proceed to this elif statement. It will also check this condition if the name is equal to Ali. So it will find that the name is equal to Ali, and then it will print that code, you are Ali. Hello everybody, welcome to this video. In this video we're going to learn about loops in Python, and we will start with the while loop. The while loop executes a block of code as long as a condition remains true. Let's say for example we had a num variable and then assign it to 5. We want to execute a block of code while num is greater than 5. While num is greater than 5, we want to print num is greater than 5. So if you run this file, it's not going to print anything because this condition evaluates to false. If you make this greater than 5, for example 15, this condition evaluates to true, and it will run this block of code as long as this condition is true. As long as this condition evaluates to true, it will run this print statement over and over again. And this condition is always true because num is greater than 5, which is 15. So if I run the file, it's going to result in an infinite loop that will never stop because this condition is never false. And a while loop will execute a block of code as long as a condition remains true. If I break out of the loop by pressing Ctrl C, it will terminate the loop. So I can also break out of the loop by using the break statement. The break statement will terminate our infinite loop immediately after the execution reaches this line of code. So it will first check if the condition is true, and it will execute this print statement because the condition is true. And instead of going back to check whether the condition is still true to execute again this line of code, it will reach this line and break out of the loop. If you run our file again, you can clear the console, run the file. So it will print the num is greater than 5, which is this print statement, and break out of the loop immediately. Let's also check another example. Let's say for example num is equal to 0, and you want to check is num less than 5, and you want to print that number saying num is, then the variable num using f string. For that we want to increment num by 1. So what this loop does is that it first check this condition is num less than 5 and num is 0. So this condition evaluates to true, and it will print num is and whatever that num is at this point, which is 0, and then it will increment that num by 1. So 0 plus 1 is 1. It will again go to the top and check the condition. Is 1 less than 5? It evaluates to true, print that number which is 1, and then increment it by 1. 1 plus 1 is 2. Checks the condition again, still less than 5, so 2 is less than 5, print that 2, increment it by 1. After it has incremented 2 by 1, num becomes 3, so it will check whether our num is still less than 5. So our num is 3 this time. 3 is less than 5, so it will evaluate to true, print it to the screen, and increment it by 1. Num becomes 4 this time. 4 is less than 5, print it to the screen, increment it by 1. Num becomes 5. It will check whether 5 is less than 5, and this condition evaluates to false, and it will not execute this block of code, and it will terminate our loop. So it will print 0 to 4, and immediately after num becomes 5, this condition evaluates to false, and it will break out of our loop. Let's say, for example, we want to skip an iteration when our num becomes 3. So if num is equal to 3, we want to continue. If I take this incrementation at the top, our loop is going to skip to the next iteration when our num becomes 3. If I run our file, it's going to print num is 1, num is 2, and when the loop reaches 3, it will continue to the next iteration and skip the current iteration, which is 3 in our case. So this continue will skip the current iteration when num is equal to 3 in our case, and goes or continues to the next iteration, which is 4. Let's talk about for loops. We use for loops if you want to execute a block of code only a certain number of times. Let's say, for example, we wanted to print numbers 1 to 5 onto our screen. So we'll be like print 1, then print 2, print 3, print 4, and print 5. As you can see, this is a very tiring process. You have to write this print statement, which is just a repetition. So instead of doing this, you can use a for loop. So for example, we will say for I in range of 5, we want to print that I. So this is more concise way, and if you run our file, it's going to print numbers from 1 to 5. So by default, the range function will start from 0 if you don't specify the starting number. Let's say, for example, we specify the starting number. We want to start from 1 to 5, and it will not include the last number. If you run our file again, it's going to print 1 to 4. We can also print the sum of these numbers in our range. Let's say, for example, we define a total variable and assign it to 0. We can add this 0 to each number in our range at each iteration. You can say total plus equal to I. So this I is each number in our range at each iteration, and it will add that to 0. And if we print this total, let's say the total is, and then use the f string to define this total variable. If you run our file again, it's going to print the total of these numbers. Let's also consider a list of fruits. Let's say we had a list of fruits that's equal to banana, mango, lemons, and apples. For example, if we wanted to iterate through each individual fruit in this list, we can use the for loop for I in, then fruits. We want to print that fruits. If we run our file, it's going to print each individual fruit in our list. And this is like saying for every fruit in fruits, or for every individual fruit in our fruits list, we want to print that individual fruit. And this I is optional, so it can be anything. It can also be fruit. So you can print this fruit If you run our file again, it's going to print the individual fruits in our list: banana, mango, lemon, apples. So this can be anything, and this is our list of fruits. Don't confuse it. The last thing we want to look at in this video is the third stepping argument of the range function. Let's say, for example, we wanted to print the range of numbers from 5 to 15. And if we run our file, it's going to print these individual numbers from 5 to 15. So this is the starting point number, and this is the end point or stopping point number. And it does not include this stopping point number, so it will stop up to 14. We can have a third argument, which is how many numbers you want to step over or how many numbers you want to skip after each iteration. Let's say we want to skip 2 numbers after each iteration. If we run our file again, it's going to skip 2 numbers after each iteration. So it will print 5, skip 2 numbers, 7, skip 2 numbers, 9, skip 2 numbers, 11, and so on and so forth. So you can specify how many numbers you want to skip over after each iteration in this third argument. Hello and welcome to this video. In this video, we'll talk about logical operators. Logical operators are used to combine conditional statements. For example, if you want to combine 2 or more conditional statements, you can use these logical operators. You can use the AND operator, the OR operator, or the NOT operator. Let's start with the AND operator. The AND operator returns true if both conditional statements of both sides evaluate to true. Let's say, for example, we had a conditional statement that says 4 is greater than 2, and another condition that says 7 is less than 19. And if you store this in a variable a, and if I try to print this variable onto our screen and run our file, it's going to return true because it will first check the left side condition is 4 greater than 2, so this will return true, and it will also check the right side is 7 less than 19, it will also return true. So this AND operator will evaluate down this true and true to 1 true. So let's say it's like saying, for example, true, and also this side true. So true and true will evaluate down to 1 true. This AND operator only checks if both of the sides evaluate to true, and if both of the sides evaluate to true, it will evaluate down to true, and if any of the sides evaluates to false, it will evaluate down to false. So let's say true and false. You clear the console, run the file again, it's going to return false because one of the sides evaluates to false. The OR operator also, if you say true or false, this OR operator will check if one of the sides evaluates to true, and if one of the sides evaluates to true, it will evaluate down to true. So if you run our file, it's going to return true, and if both sides evaluates to false, it will return false. The not logical operator takes one boolean value and it will check if something is not true or it's not false. So let's say, for example, not true will evaluate to false because if something is not true, obviously it's false. So not true equal to false, not false will equal to true. So it has only one boolean value. Hello everyone, welcome to this video. First of all, I want to congratulate you for coming this far. We have covered most of the basic Python concepts that we needed for this course. In this video, we're going to look at the last concept that we needed in this course, which is a module. A module is a file that contains a set of functions that you want to use in our application or in our program. And if you want to use a module in our program, you have to import it using the import keyword. For example, let's say we want to import the math module. We will use the import keyword followed by the name of the module, which is math. This math module will give us access to a bunch of functionalities that you can use in our program. For example, if you want to find a square root of a number, you will use this math module and then dot square root function, and then the number that you want to find is square root. So it will give us access to this function that you can use to find the square root of a number. Let's store this in a variable a and print this variable onto our screen. If you run our file, it's going to return the square root of 16, which is 4. So the point is, these modules will give us access to these functions that you can use on our programs. Let's see the random module. So if you want to generate a random number, you will have to import the random module. And this module will give us access to functions that you can use to generate a random number. For example, if you want to generate a random number between a certain range, you'll have to use random.randint, and this randint function will generate for us a random number between, or a random integer between a certain range. For example, let's say we want to generate a random integer between 1 and 10. If we store this in a variable, into the screen and run our file, it's going to return a random integer between 1 and 10. It has returned 3. If you run our file again, it has returned 8, 8, 8, 10, 8, 2, 1, 6, 4. So this randint function will generate for us a random integer between a certain range. So for example, you have specified between 1 and 10.